friends, welcome to Quick Learn tutorial series. In this video, I will explain you PLC operation and CPU scan cycle. This is lecture number 6 of PLC and SCADA series. So let's start with the topic. So before I discuss PLC operation and CPU scan cycle, we must know about what do you mean by PLC, the basics of PLC, the application of PLC, why we use PLC and where we use PLC. For PLC or the basics of PLC, I have already made a video on that. The link of that video I will give in my description box. So please go to that link and learn the basics of PLC. But in this video, I will first give a brief introduction of PLC. PLC stands for Programmable Logic Controller. So the name suggested, it is a type of controller or it is a device that performs controlling function according to the given logic. So basically PLC is used for control any machine, any process, any production line, or we can say that PLC is basically used for industrial automation. PLC is basically a hardware microprocessor based controlling system. So we can say that the core of every PLC is a microprocessor. So we can say that PLC is basically a industrial computer. So the processor of the PLC perform various operations, just like it gather input from the various field input devices and evaluate them to achieve the desired output, to perform some controlling function just like process control, machine control functions, etc. We know that PLC is basically a multiple input multiple output system. There are number of inputs in PLC and number of outputs also. So the input in PLC is given in any form, any physical form, digital form or analog form. And just like in physical form, we give input in the form of pressure, temperature, humidity, etc. In digital form also we give input, or in analog form also we apply input in PLC. So the user can program the system in multiple way to fit a certain scenario. PLCs within many applications across various industries, just like it include conveyor systems. Oil and gas refinery also use PLC system for automation. Manufacturing lines or production lines also use PLC, and just like wastewater treatment plant also use PLC. So there are wide variety of applications of PLC. Now, as I have already told, PLC is a microprocessor based controlling system. So PLC take microprocessor as the core and has many characteristics of microcomputer, but its working method is very different from microcomputer, because microcomputer generally work in waiting mode, whereas PLC work by centralized controlling system, just like it having a centralized input, it having centralized output and periodic cycle scanning. So the time used for each scan is called scan time and the cycle is known as scan cycle. So in this video, I will explain in detail what is the PLC CPU scan cycle or scan time. Now I will explain you how CPU work. As I have already told, PLC is a programmable logic controller. It means it is a controller that can be programmed according to the given logic. So this program is done by a programmer according to the given logic which is to be performed, and the controlling function is to be performed by CPU. So this program is basically, we know that a group of instruction. So when we start PLC, the CPU get started and CPU start execution from the first instruction and execute the instruction one by one in the sequence to perform periodic program loop scanning. If there is no jump instruction, the user program is executed sequentially from the first instruction to the end. At the end of instruction, CPU again return to the first instruction and so on. So in this way, CPU perform the scanning, and this is called the scan cycle of CPU. Now, In addition to executing the user program during each scan, the PLC must also complete some other internal processing function, just like input sampling function, communication service. Communication service means PLC CPU communicate with all the other component connected in the PLC system. Program execution, this is the main function of PLC CPU, and self diagnosis, it means self testing is also done by the PLC CPU, and update output or output refresh function. So these are the other function that is also performed by CPU. So in this way PLC CPU get work. Now all the functionality of PLC CPU or PLC scan cycle I will explain with the help of this diagram and the block diagram of PLC. First, I will explain in brief the block diagram of PLC. This is the block diagram of PLC. This block diagram show how the number of components connect together to make a complete system to control any process or any manufacturing plant or automate industry. So as I have already told, PLC is a in multiple input multiple output system. So these are the multiple input and these are the multiple output of PLC. In PLC, input is given in any form, any physical form, analog form or digital form. So here we use some input sensing device to given the input. These sensing device, here we use generally sensors or switches. The function of the sensor is to convert one form of energy into electrical signals. So these sensor convert any form of energy, just like if we give humidity. So here we use humidity sensor, and this humidity is converted into electrical signal. This electrical signal is given to the input module. Now the function of input module provide interfacing between the input sensing device and the central processing unit. It means it convert the electrical signal into the digital signal that can easily processed by the CPU. Now what CPU do? So the function of the CPU contain memory also. So there are two type of memory in PLC, program memory and data memory. In program memory, application specific program or user specific program is written in the program memory. So here we use ROM as a program memory. So for programming, here we use externally a programmable device which is connected through PLC with the help of this Ethernet cable. So this user specific program is stored in the program memory of PLC, and data memory contain the input data and the output data. So data memory, here we use RAM, and this is divided into two parts, the input section and the output section. So when we start PLC, CPU get start and perform the input read operation. So CPU read input from the input module and store in the input section of data memory. Now CPU fetch the program from the program memory of the PLC, then process or execute the program, and the output of that program is stored in the output section of the data memory. After that, when all the functioning is completed or all the program get completed, this output is given to the output module, and output module show the output with the help of output load device. So this is the whole functionality of the PLC system. Now what is CPU scan cycle? CPU scan cycle means CPU perform three functions: input read, program execution and update output. When we start PLC, CPU start input read operation. It read input from the input module. Then next operation performed by CPU is program execution. So program is the collection of instruction. CPU take one instruction at a time, then execute that instruction by using this input and execute that instruction and update the output. When this instruction or output get updated, the scan is end. This is called end of scan. Okay, now again CPU go to the first step. Again CPU read input, then program execution, then update output. This three process or three step is called one scan cycle. So CPU again and again multiple time perform these three operations. So this is called CPU scan cycle. In one scan cycle, CPU perform one instruction at a time. So this is called CPU scan cycle. And the time taken for one scan cycle is called scan time, or we can say that CPU scan time is the time taken to read input, time taken to solve logic or program execution, or time taken to display output. So the sum of these three times is called CPU scan time. Basically, different PLC having different scan time. So the PLC scan time varies from 0.1 millisecond to 50 millisecond. It depends upon many factors. First, the number of input in the PLC system. If number of input is less, so the scan time is also less. If the number of input is high, so the scan time is automatically high, because if PLC CPU read only 5 inputs, so the scan time is small. If PLC CPU read 50 or 500 input, it will take time. So the scan time depend upon the number of input in PLC system. If in number of input is high, scan time high. Number of input less, scan time less. Next factor is length and complexity of the logic or program. The CPU scan time also depend upon the length of the program. It means if the program is short, the CPU scan time should be less. If the program is lengthy, so the scan time should be lengthy. And the complexity of the program. If high complex instruction or program is written, just like PID program with PID instruction, so the scan time is high. If we use number of timers, counters, number of NCNO contact in the program, so the length of the program and the complexity of the program get increases, and that affect the scan time of the CPU. Scan time is also increasing. Now next is the number of output. If number of output is less, scan time less. Number of output high, scan time increase. Next is the amount of memory taken by the program. How much memory taken by the program is also affect the CPU scan time. Next is the speed of CPU or operating system. If the speed of CPU is less, so scan time is increased. If the speed of CPU is faster, so the scan time is faster. So it's depend upon many factors. So if we want a faster PLC system, the CPU scan time should be small. Basically, PLC is a field device, so there are so many factors that affect the PLC scan time. So the question which is very much popular in examination point of view or in Viva, how PLC CPU scan time is related with input and output device. This is very important question. This question is very frequently asked in the interview or the competitive exams. So the answer of this question I will explain with the help of this diagram. Suppose this is a PLC and this PLC is connected with the input device. Here we use encoder as an input device. So the encoder give input. The frequency of encoder is 1 millisecond and the scan time of PLC is 5 milliseconds. Here we see this is the scan time of the PLC. As I have already told, this is first scan cycle and this is second scan cycle of PLC. The PLC scan cycle we assume 5 millisecond. So the total scan time of PLC is divided into three parts. First part is the input read section. Next is the logical solving or program execution part, and third is the output read or update output part. So let us assume if PLC take 0.3 millisecond to read the input and PLC take 0.3 millisecond to update the output. So how many time remaining to execute program or logic solving? So 0.3 plus 0.3, 0.6 millisecond. Now minus 0.6 millisecond from 5 millisecond, there is 4.4 millisecond. So this is the time PLC used for program execution. Now this blue indicate that this is the encoder input. As I have already told, encoder input frequency is 1 millisecond. So encoder give this first input pulse. This is second input pulse of encoder. This is third input pulse. This is fourth input pulse. So the input pulse appear in the input read time. this input, first input pulse is appear in the input read time of the PLC. Second input pulse is appear in the program execution or logic solving time of PLC. And third input pulse appear in the output read time of the PLC. And fourth input pulse also appear in the input read time of the PLC. So in this case, PLC only read first pulse and fourth pulse, because these two pulse are appear in the input read cycle of the PLC CPU scan time. But PLC not read pulse number second and pulse number third, because the pulse number second and pulse number third appear in the logic solving or output read time, which is not come in the input read time. So if the encoder frequency is high, the input is not read by the PLC properly and PLC not show the accurate output. So we can say that if the input frequency of the input device is higher than the PLC scan time, the device get not synchronized with the input device and the PLC does not show the accurate output. So we can say that the input device and the PLC should be synchronized. It means the PLC scan time should be faster and the input frequency should be less. Now next function in PLC is interrupt function. What is interrupt function and why we use interrupt function? Let us assume if PLC input and the PLC scan time is not synchronized, then what we do to obtain the accurate result in PLC output. So let us assume this is the PLC scan time, this is PLC scan 1 cycle and this is scan 2 cycle. Scan 1 cycle is divided into 3 parts. First is input read time, the next is program execution or logic solving time, and third is update output time. In scan 2 again input read time, program execution and update output time. Now this is the frequency of the input signal or input signal. First input signal appear in the input read time, second appear in the program solving, third is also appear in program solving, and fourth is also appear in update output. So if this mismatching is occur between the PLC scan time and the input signal frequency, so the PLC does not give the accurate output and PLC not read this second, third or fourth number of pulse. So what we do? So here we use interrupt function. Before giving the input signal, we send the interrupt request signal. When PLC CPU read this interrupt request signal, CPU understand this signal is immediate or urgent signal. We read this signal and then we execute the program. So I will explain with the help of diagram. Every time when we give input signal, we add a interrupt request signal. So in this first pulse we add a interrupt request signal, second pulse we also add interrupt request signal, third we also add interrupt request signal. If this interrupt request signal is appear in the input read cycle of the PLC scan time, the PLC CPU reject this interrupt signal and read the input signal as normally. But during the logic solving time or update output time, if input signal is appear with interrupt request signal, then what PLC CPU do? PLC CPU immediate pause the current execution of program and read this input signal, because if interrupt request signal is added with the input signal, CPU understand this is the urgent signal and we have to read this signal. So CPU when read this interrupt request signal, CPU hold the current execution of program and read this input and execute the program, and output is stored in the output section of RAM. Then again when CPU see next pulse of the input signal with interrupt request signal, then again CPU process this input signal. It means read this input signal, execute this input signal, and the output is stored in the output section. After that, when all the input pulse is read by the PLC, then PLC go back to its previous work or resume its previous operation. So in this way we perform interrupt function in PLC. So this is called the interrupt function of PLC. So hope you like the video. For more interesting video, please stay continue and keep watching and keep sharing my videos with your friends.